हेलो नमस्कार दोस्तों। आज हम देखेंगे एग्जाम्पल ऑन माइनर लॉस ऑफ एयर फ्लो थ्रू द पाइप। तो हमारे पास क्वेश्चन है a sudden enlargement of water from 240 to 480 mm diameter. The hydraulic gradient rises by 10 mm. Calculate rate of flow. So here in the question we have given two diameters, that is 240 mm and D2 which is 480 mm. It is the enlargement, which means the pipe having a smaller diameter, then it is increases abruptly or suddenly. So this is 240 and this is 480 mm. Okay, the hydraulic gradient rises by 10 mm, means hydraulic gradient is nothing but the sum of potential head plus pressure head. Okay, potential and pressure head, which has been PW by P by W plus Z is the formula of hydraulic gradient, which is increased by 10 mm. So we can say that P2 by W plus Z2 minus P1 by W plus Z1 is equal to 10 mm, which means diameter, the hydraulic gradient in the bigger section is increased 10 mm when the fluid passes through smaller diameter to the outer diameter. Okay, so we have to here calculate the rate of flow. Okay, so this is the rate of flow we have to calculate. So rate of flow is nothing but the quantity flowing through a particular section. Okay, so if we use head loss, we will found the loss of head, not the quantity or rate of flow. Okay, so here we have to use Bernoulli's equation. Bernoulli's equation, which states that P1 by W plus P1 square by 2G plus Z1 is equal to P2 by W plus P2 square upon 2G plus Z2 plus HE, head loss, because the increase in the diameter result in the loss of head. So loss of head is added in the section 2. Okay, so we have the value of P1 minus by W, P2 minus W, okay, and Z1. Okay, here we have to find out the velocity at both the section. Okay, so here we know that HE, that is head loss of head, you can also say that loss of head is for the sudden enlargement is P1 square minus P1 minus V2 whole square by 2G is the formula of loss of head. So here in this section we will use continuity equation. Continuity equation states that the quantity is flowing from the pipe will remain same if no fluid is added and or removed from the pipe. Okay, so we have A1 V1 equal to A2 V2. So here V1 equal to A2 V2 minus A1. Here area of second section, it is nothing but the pi by 4 into D2 is 480 square into V2 pi by 4 into 240 square. So here we will get answer 4 V2. You can put this value, this pi by 4 and pi by 4 is cancelled, 480. You can write here in meters also 0.48. The answer will be same. I have not written it, so you can correct it. Okay, so the answer, that is V1, therefore V1 equal to 4 V2. Okay, so we have given this equation, so we will put this value in the Bernoulli's equation, that is equation number 1. Give the Bernoulli's equation as equation number 1. So put into equation 1. Okay, so P1 by W plus P1 square by 2G plus Z1 equal to P2 by W plus P2 square by 2G plus Z2 plus HE. Okay, so now you can do that, you can interchange their positions. So you can do here V1 square by 2G and minus V2 square by 2G minus HE. Okay, equal to P2 by W plus Z2 minus P1 by W plus Z1. Okay, so we have, you can see here we have this value for potential hydraulic gradient is 10 mm, so we can put here this value directly. So here you can say that 10 mm means 0.01 meter. Okay, and diameters are 0.48 meter and 0.24 meter. So yeah, I think you are able to see it. Okay, the small correction should be made, and you have to consider most all of the measurement of diameter and length in meter in hydraulics or fluid mechanics. Okay, so we have the value for V1 is 4 V2 square, as you can see here in equation 2. So you can do that 4 V2 square by 2G minus 2 square by 2G minus HE. So HE means V1 square minus V2 square. Okay, so HE means V1 square, V1 minus V2 whole square. So you can here write 4 V2 minus V2 square upon 2G. Okay, equal to, here we can write 0.01, as we have the value of hydraulic gradient, rise is 10 mm. So here 16 V2 square on 2G minus V2 square upon 2G minus 4 minus 1 is 3 means 9 V2 square by 2G. Okay, equal to 0.01. You can put sorry, you can directly do one thing, that you can subtract 16, 9 and 1 from 16, which is, it is 10 and it is 6. So 6 into square by 2g equal to 0.01. If you put the value of g, so you will get, and take under root for v2, so v2 will be 0.181 meter per second. So this is the value of velocity of fluid or liquid in the enlargement enlarged section. So we have to find out the quantity. So you can do that. Q equal to AV, means area is pi by 4 into 0.48 square into, this is the formula for area, and the velocity we have is 0.181. So we will get answer 0.0375 meter cube per second. So we have given v1, so you can also calculate v2, and we have v1 equal to 4 into 0.181, which is equal to 0.724. And you have, if you calculate the quantity in the that section, so you will get A equal to V 5 by 4 into 0.24 square into 0.724. So here you will get answer 0.0327 meter cube per second. You will find the both the values are nearly equal, as they have the difference after 0.3 decimals. Okay, so this is our right click. So our answer is correct. You please like the video, comment and share with your friends. Thank you for watching. धन्यवाद.